Okay, today's lesson is called Inscribed Angles. Inscribed Angles. So far, we've talked about circles. We've talked about the area of circles. We've talked about the circumference of circles. You know that this is called a radius, that this thing right here is called a diameter. You just learned yesterday that if you have a line that intersects exactly once on that circle, it's called a tangent line. The tangent line is going to be perpendicular to the radius, and it's also going to be equal to the slope, the instantaneous slope at that point. So that is what we've learned so far. Let me give you another term really quickly. If you go over and have a point on the circle and you have any other point on the circle and you connect them, that is called a chord. We have tangent, which intersects exactly once and it's a line, and then you have a chord, which is a line segment with both endpoints on the circle. Does anybody have any questions on that? We also learned about arcs. If you have this central angle, and this central angle, let's say, was 70 degrees, then what is going to be the measure of this? Not the length of it, but the measure in degrees. The arc would be how many degrees? 70 degrees as well. So you know the central angle is equal to the arc. Okay, that is what we know so far. What we're going to do now is we're going to be talking about something called a inscribed angle. So what I did here was every single one of these are inscribed angles. These ones are not inscribed angles. What I want you to do is talk to a person next to you and come up with the definition of what an inscribed angle is, and make sure you have the word vertex somewhere in your definition. People at home, I want you to pause the video and try to think up a quick definition for an inscribed angle. Okay, kiddos in class have talked about this for a little bit. It is going to be an angle inside the circle. And then what did you guys get?
We said that there has to be the vertex touching the inside of the circle
Good.
at some point.
Vertex on the circumference. I heard someone else saying that these were the angle was made with two whats? What did we just call it if you go from one point to another point? A chord. So you got two chords, and those chords are going to go ahead and make your inscribed angle. Does anybody have any questions on that?
What is that? An inside what?
An inside, oh, that's funny. Inscribed angle is an inside circle, is an angle inside the circle with, there's not a with, there we go, with the vertex on the circle. Okay, now what you guys are going to do is I want to know what this measure is. Like, how do we find the measure of this angle? So what you're going to do in just 1 second is you have a gigantic circle. If you flip your note packet over, you have a big old circle. I want you to pick any 2 points. So the point could be here and the point could be here. It does not matter. You are then going to make the angle that is the central angle. The nice thing about this is if you have the central angle, then you already know what the arc is going to be. And if you know the arc, then you know the central angle. Then you are going to go over and make an inscribed angle that goes to those same exact points. Once you do that, figure out what this angle is by measuring it with a protractor, and then measure this angle with a protractor and try to come up with some kind of a rule. Like if I go over, this is the goal. If I gave you that this was 100 degrees, what is this? Try to use your little investigation on the back using your protractor. Once again, if this was an arc of 100 degrees, what would this angle be? And your investigation is going to teach you that rule. People at home, let's just give the kiddos in class just a second to do the activity. All right, so kiddos at home, basically what ended up happening is on the back side of the notes, the kiddos found out what this central angle was, and then they made an inscribed angle that goes to that same exact arc. They found out, let's say this was 50 degrees, which means the arc is also 50 degrees. And then they went over and measured this, and let's say they had 50 and 50 on there, then they would have gotten 25. And the students in class realized that that meant the measure of the inscribed angle is going to be 1/2 the measure of the intercepted arc. And the arc will be double whatever the angle is. So basically you are trying to find an angle. If you know the angle, then you just double it to find out what the arc is. If you have the arc, then half it and you'll know what the angle is. Anybody have any questions on that? So let's go ahead and do them here. This is usually really easy for students if I just have it like this. This is 100 degrees. What is x? Because they can see that this 100 degrees is corresponding to the x here. So they just half it. But when you go over and throw in a bunch more chords, kids' brains freak out. You need to be able to ignore a bunch of stuff. For example, to find A, you need to figure out the angle that goes and is corresponding to it. So this goes from here to here. That's what A is corresponding to. So that would be this chord and this chord. So if those are the two chords, and between the chords is 60 degrees, then A must be how many degrees? 30 degrees. Really? No, we got to double it. So that's the big thing that we mess up on a lot of times. People accidentally go over in half when they're supposed to double and double when they're supposed to half. So that would be 120 degrees. Does anybody have any questions on that? Let's switch to a different color. Okay, so on this one, B is what two chords make B? Well, that would be this chord, and that would be this chord. Those are the two chords that make B, which means it corresponds to, or it intercepts this whole entire arc here. We already found out that A was 120 degrees. So what is that whole arc now going to be? 150. If that's 150, then B is going to be double it or half it? Half it, and then you get 75 degrees. Does anybody have any questions on that? It might be helpful to go over and use different colored pens or something like that. All right, let's go ahead and do two more together. So on here, you're either hoping you have the arc so you can find the angle, or you have the angle so you can find the arc. So A on here, A, I'm going to get a different color because I'm not a big fan of this one. Red. Okay, this angle right here corresponds to which arc? How many degrees is the arc that it corresponds to? 42. So here's 42 degrees, so A must be half of that, which is 21. Now B, on the other hand, it's like a flashlight, and it's shining out onto the circle. That is going to intercept which arc? The arc that is a measure of 84. So that means that B must be half of that, which is 42. Now here's the tricky part. Is angles where the C is that an inscribed angle? Does it go all the way to the other side? No. Does it go to the center? No. So we are in bad shape now, because we knew if it went to the center, it would be equal to the arc. If it went all the other side, like an inscribed one, it would be 1/2 of it. Can anybody think of a way that we could figure out C? Yeah. Something's a little funky. Miss Kim. Linear pairs. Yeah. I guess if you knew this one, then yeah, that would be a linear pair, but we don't know that angle. Yeah.
You could do is you could use vertical angle theorem, plus C on the other side.
Great.
And then use A plus B plus C equals 180.
Fantastic. The triangle angle sum theorem is going to say there's 180 degrees in that triangle that's in there. We can subtract away the 21, and we can subtract away the 42, and we can find out what's left over. Someone with a calculator, tell me what 180 minus 21 minus 42 is. 117. So if that angle right there, which they didn't even ask for, was 117, then what is C going to be? 117 as well. So the big thing on here is, even if they don't ask for something, you always try to put in all information that you can. If we could have figured out what this arc was, even though they didn't ask for it, we should really go over and write that in. Yes?
So how is the original C not an inscribed angle?
Okay, so by definition of an inscribed angle, a central angle is going to have the vertex at the center. An inscribed angle is going to go all the way to the opposite side. This one was not at the center and was not going all the way to the other side.
Oh, so the vertex,
Neither.
the vertex was on the opposite
Correct. Yep. All right, now this problem is really, really hard if I don't show you a little trick. So let's take a look at a little trick here. This only works if you have a four-sided figure, a quadrilateral inside. So let's say we had this. I want to know, how is that angle and this angle related? So what I'm going to do is I'm going to use some different colors here. We know that this angle right here is going to correspond to this arc. Get a different color, black. this angle right here is going to correspond to this arc. What do you notice about those two arcs together? It's covering the whole circle, which is 360 degrees. And we know the angles are half of it. So that means that these two angles must add to be how many degrees? 180. Okay, what this tells you, if you have any time that you have a four-sided figure in here, this angle plus this angle have to equal 180. This one and this one have to equal 180 when you add them together. It saves time. If this thing was a pentagon in here or something like that, you wouldn't be able to do this. This only works if it is a four-sided figure. So let's go ahead and run through this. Let's just do the easy ones. If this is 108 degrees, then A must be how many degrees? 72 degrees. Fantastic. Because that one, 108 plus 72 equals 180 degrees. Questions? If this one's 92, then this one's going to be how many degrees? 88. Does anybody have any questions on that? Okay, at this point, I'm going to try to delete out all the stuff we did just so that we can have a little bit more room. Let's delete all that out. Okay, so at this point, I'm going to change it. Okay, so we said that this one was 72 degrees and this one's 88. Now we have to figure out all the rest. So some of the things you can do, for example, this is 108. So how much is the whole entire arc going to be from here to here? 216. And we already have 114 of that accounted for, so what is left for C? 102. Anybody have any questions? How are we going to find D? Oh, I know how we can do this. Okay, so this chord goes to there, this chord goes to here. That's 80 degrees, which means going from here all the way over to here is going to be 160 degrees. We just found out that C was actually 102. So if you had that 160 and you took away the 102, how much is left over for D? Is B 88? Okay, it is 88. So that I messed that up. So this one would be 176. Okay, and then what's left over? Remind me for your extra credit point later on. 74. There you go. So there's many different things you guys can do here. You can do the fact that a central angle is the same as the arc. That's half of the arc. All of the arcs together are 360. Half of the circle is 180. You can do a bunch of different things. Anybody have any questions? So here are some extra things that you can use when you're using your logical reasoning. If you have two angles that are going to the same arc, then what must be true about those two angles? They must be congruent. So if this angle goes to this arc, it's half of the arc. If this angle also goes to the same arc, it's also got to be half the arc. So they're going to be congruent. Does anybody have any questions on that?
What?
So think about this. If this angle went to this arc, let's say that arc was 100, then this has got to be 50. Any other angle that goes to that same exact arc also has to be half of it, which is 50, or whatever the number is. Okay, the next one. This angle right here is going to go to half a circle. How many degrees is half the circle? So therefore, the angle must be how many degrees? 90. And that means it is right. Any questions? And then lastly, we just talked about why this works, but the opposite angles inside of a quadrilateral that's inside of a circle are going to be supplementary. They add to be 180. And I showed you why that was. This angle is going to go to this arc. The other angle is going to go to the other arc. And since it covers the whole circle, which is 360, half of that would be 180. Questions? Let's do an example. So on here, red. Let's do the easiest part that we can. Actually, you guys choose. Do you want to solve for 1, 2, 3, or 4 first? Doesn't matter. 4? Okay. So this is 140 degrees. So angle 4 is going to be how many degrees? 70. We know that this angle must be supplementary to the 70. So how many degrees is that going to be? 110. We also see that angle 1 is going to half a circle. Half a circle is 180, so 1 has to be how many degrees? 90 degrees. And you know the 1 and the 3 are supplementary, so 3 must be how many degrees? 90 degrees. Yes.
Wait, so for angle 4 and 2, don't they go to the same?
No, take a look. So 4 is going to this little r arc right here. It intercepts there. And then 2 is going to this big old arc right here. Does that make sense? Okay. All right, we have talked about if you have a chord and another chord, this is called an inscribed angle, and it's half of that arc. What we're going to do now, though, is the question becomes, what about if it was one chord and then it was a tangent instead? Instead of two chords, it was one chord and a tangent. So this little drawing should explain to you what it's going to be. This angle right here is going to be how much of this arc? That's an inscribed angle, and it will be half of the arc. How about when I start moving it? It's still an inscribed angle, so how much of the arc is it going to be? Half. I did it again. It's still an inscribed angle. How much of the arc is it going to be? Half. Ah, it's finally no longer a inscribed angle because you have a chord and a tangent. What is this going to be? It's going to be the same thing. It's just going to be half of this arc right here. Does anybody have any questions on that? So it basically says the measure of an angle created by a chord and a tangent is also going to be 1/2 of the measure of the intercepted arc. And an intercepted arc would be, if you go over and you shine a flashlight from here, where is it hitting? All right, we got 2 more problems, and I'll do the first one with you. I'll have you guys do the second one, and then you guys can get started on your homework if we have some time. So we're looking at this. The only way I can find out y is if I know what this arc is. Do we know that arc? No. Now we do know that this is 35. If you know an angle, you can follow across and find out what the arc is. It might help you, it might not help you, but I'm going to write it in just because we have it. Green. How many degrees is this arc right over here going to be? How many? 70 degrees. And if that arc is 70 degrees, then what is the angle between the tangent? The angle between the tangent and the chord. Angle x is going to be how many degrees? It corresponds to an arc of 70 degrees. So the angle must be how many? 35 degrees. 35 degrees. Now, I don't remember how I got y. Does anybody have any ideas? How do we get y? Because y's got to go, the only way I can think of getting y would be if we knew this arc, and if we know that arc, then we half it. And that gives you the angle.
Oh, because the triangle is a semicircle thing right there.
That's a semicircle, which is 180 degrees, but that doesn't give us a y, but it will give us that this angle is, there we go. Okay, so even though they didn't ask for this, without doing this, you couldn't have found y. Because now we have 180 degrees for the whole entire circle. I'm taking away 90 for the, because it corresponds to a semicircle. That gives you 90 degrees, and then you subtract 35, which already exists, and that gives you 55 degrees? 55 degrees. Anybody have any questions on that? People at home, please go ahead and pause the video. Try problem 2. People in class, go ahead and try to do number 2. Let me go ahead and pause the video. All right, these should be fun. They're little games, and at first, you don't have many open doors. There's only certain variables you're going to be able to solve for first, but once you start filling in those, it opens up some more doors. For example, you cannot do A because you don't have D. So let's try to figure out what D is. Well, we know this whole entire thing is going to be 180 degrees. So how much is left over for D? 70. Well, now we have that. And if that's 70, then this one is going to be half of that, which is 35. E is easy because if this is a chord and that's a chord, then that intercepts this arc, which is 76. So E must be how many degrees? 38. Great. That's 38 degrees. B is corresponding, if you shoot out those chords, it's going to correspond to the 110. So B is going to be how many degrees? 55. And lastly, I know that this going all the way to here is 180 degrees. You have 76 of that accounted for. How much do you have left? 104. So the arc is 104, and the angle must be half of that. So it's going to be how many degrees? 52 degrees. You can see these get really messy. Okay, let's just recap on everything you've learned so far. We learned that if you know the central angle, you know that this arc is going to be the same as the central angle. If you drop that down so that it's no longer a central angle, but it's an inscribed angle, then it's going to be 1/2 of the arc. Also, if you have a chord and a tangent, the angle between those is going to be half of this arc as well. You also have triangle angle sum theorem you can use. You know a full circle is 360, and we have some other little tools that you can attack these problems with. Any last minute questions? None? All right, people at home, thank you so much for watching.